Some islands were never connected to the mainland, yet ancient humans were already living on them. There are islands in the Mediterranean that were never, at any point in human prehistory, connected to the mainland by land. And yet archaeologists keep finding obsidian on them, a volcanic glass that only comes from specific mainland sources dozens of kilometers away. The nearest source for the obsidian found on Melos, for example, is the island of Milos. And getting there required crossing at least 120 kilometers of open Aegean water. This was happening as far back as 13,000 years ago, during the Mesolithic, long before farming, long before anything we associate with organized society. Human remains have turned up on these islands too, and the question those bones raise is not just how people got there, but whether they ever made it back. Here is the frustrating part. The boats themselves are almost entirely gone. Wood rots, reed bundles dissolve, skin-covered frames fall apart within decades. The oldest confirmed watercraft we have found anywhere in the world is the Pes canoe from the Netherlands, a hollowed pine log dated to around 10,000 years ago. So archaeologists work backwards. If the tools are on the island and the stone to make them is not, something carried the people who made them across the water. It is not just tools. Certain animal species, deer, wild boar, even small cattle, appear on islands where they could not have swum. Someone brought them deliberately. The craft were probably reed bundles, log rafts, or skin boats, simple enough to build with stone tools, capable enough to carry a small group and a few animals across calm water. The same pattern appears in the North Sea basin. By 8,000 years ago, people were crossing between what is now Britain and the European continent, water gaps of 30 kilometers or more. There were no charts, no compass, no systematic knowledge of the stars passed down through generations of sailors, just open water and whatever land you could see from the shore before you left. The critical problem was commitment. Once you were far enough out, the shore you left was gone. The shore you were heading for might not yet be visible. You were simply at sea. What they likely used were birds, wind direction, wave patterns, and the color of the water. The same cues Pacific navigators relied on thousands of years later. Crossings almost certainly happened in calm weather windows, early summer when the sea was flat and the prevailing winds were predictable enough to be useful rather than lethal. But not every crossing was planned. A fishing trip pushed off course by a sudden wind shift could carry a small group beyond any hope of return in a matter of hours. At some point in that situation, turning back was no longer an option. The only rational move was to keep going and hope something was on the other side. When geneticists analyze ancient DNA from early island populations, they find something striking. The genetic diversity is extremely narrow, consistent with founding groups of perhaps 5 to 15 individuals. This is called a genetic bottleneck. When a very small group founds a new population in isolation, the genetic variation of everyone who comes after them is limited to whatever those few individuals happen to carry. Sardinia is one of the clearest examples. Its earliest Neolithic population shows a bottleneck so severe that researchers estimate the founding group may have arrived in as few as 2 or 3 separate crossing events. Skeletal evidence from island burial sites adds another layer. The age profiles of the dead, how many were young adults versus elderly, can suggest whether a population was growing or slowly dying out. Some island burial populations show almost no evidence of ongoing contact with the mainland for centuries after the initial arrival. Those people did not go back. They could not. But other islands show the opposite, repeated arrivals of new genetic material, new tool styles, new animal species over hundreds of years. Those crossings were not accidents. They were routes. When the same distinctive tool-making technique appears on both sides of a water gap within the same century, it means knowledge was moving. And knowledge does not move without people. The honest answer to whether these voyages were deliberate or accidental is that they were both, and the distinction probably did not matter much to the people making them. Some crossings were clearly intentional. You do not accidentally bring a breeding pair of deer and a supply of seed grain onto a raft. That requires planning days or weeks in advance. But the genetic bottlenecks on some islands are so extreme, sometimes consistent with just 2 or 3 reproductive adults, that deliberate colonization alone cannot explain them. Those numbers suggest catastrophe. Imagine being carried off course with 3 other people and landing somewhere you had never seen. No way back. No knowledge of what was on the other side of the next ridge. That was the situation. And yet they survived. They built shelters. They managed the animals they had brought or found. Within a few generations, the island was home. Not a place they had been stranded, but a place they had made. What this tells us is that early maritime movement was not a story of bold explorers with a plan. It was a story of people who ended up somewhere new and figured out how to stay alive once they got there. The sea did not stop them. It redirected them. And every island population that survived a crossing, planned or not, is proof that the instinct to keep going is older than any map ever drawn. If this made you think differently about your ancestors, subscribe. There is a lot more where that came from.